Good morning, all. Welcome to the class. Today we'll discuss the various types of chemical reactions. First one is combination reactions. A reaction in which a single product is formed from two or more reactants is called a combination reaction. In short, we can write A plus B giving rise to C. Here C is the product. So a single product is formed from two or more reactants. Coming to the example of combination reaction, first one we will discuss. This is addition of quick lime and water to form slacked lime and heat. Calcium oxide is our quick lime. It is reacted with water to form calcium hydroxide, which is called slacked lime, and heat is generated. So here we can see two compounds, calcium oxide and water, react together to form one substance, that is calcium hydroxide or slacked lime. Coming to next example, we have burning of coal. This carbon is one element. It's in the solid form and it combines with oxygen to form carbon dioxide, which is gaseous instead. So this is also one example of combination reaction. Third example we are going to discuss here is formation of water. Water is formed from the gases hydrogen and oxygen. Hydrogen and oxygen combine together to form water, which is liquid. So this reaction is balanced. For balancing, we have multiplied 2 in the water side and 2 in the hydrogen side, in the reactant side. Next, come to decomposition reaction. A reaction in which a single reactant breaks down into two or more simpler products is called a decomposition reaction. In short, we can write D is a reactant which gives rise to E plus F. So from one single reactant, two or more products are formed during this reaction. Here is one important example of decomposition reaction. So we are taking ferrous sulfate, which are initially hydrated and green in color. The formula is FeSO4 7H2O. 7 molecules of water is attached with 1 molecule of ferrous sulfate. When heat is given to it, it first loses its water to give ferrous sulfate. This is anhydrous, means it has lost its water. So initially it was green in color, and it is now, after giving heat, it becomes white in color after losing the water. On further heating, this anhydrous ferrous sulfate is broken into ferric oxide, sulfur dioxide and sulfur trioxide. A sulfur dioxide and sulfur trioxide are gases. Ferric oxide is solid, which are formed from the breaking of ferrous sulfate, which is again solid. So it is an example of decomposition reaction. The below one, the ferrous sulfate is broken into ferric oxide, sulfur dioxide and sulfur trioxide. So one reactant is broken into 3 products. Coming to the next example, this is decomposition of calcium carbonate, which is also known as limestone. So when heat is given to the solid calcium carbonate, or limestone, it is broken into calcium oxide, which is also known as quicklime, and carbon dioxide. So it is an example of a decomposition reaction where one reactant, that is calcium carbonate, is broken into calcium oxide and carbon dioxide. The third example is breaking of lead nitrate or decomposition of lead nitrate. When lead nitrate is heated, it forms lead oxide, nitrogen dioxide, and oxygen. This nitrogen dioxide and oxygen are gases in form. This lead oxide is solid. Nitrogen dioxide, it comes out in the form of brown fume. See this reaction which is written, it is a skeletal equation. It is not balanced. Now we'll balance it. As oxygen is present in all three products, we will not first balance oxygen, we will balance other elements. See, in the left side there are two nitrogens, but in the right side only one nitrogen is there, so we will multiply 2 there in the product side. Now see, in the left side one lead atom is there, right side one lead atom is there. In the left side 2 nitrogen atoms are there, in the right side 2 nitrogen atoms are there. In the left side we see that 6 oxygen atoms are there, and in the right side if we will count, then we will find 4 to 6 1 7 oxygen atoms are there. So what we will do, we will multiply half to the oxygen molecule. Now after multiplication of half to the oxygen molecule, the equation is balanced, but half oxygen does not exist, hence entire equation will multiply by 2. Means in the reactant side will multiply by 2, and in the product side also will multiply by 2. So now we have multiplied 2 on both the sides, in the reactor side as well in the product side. Now we will derive the equation. So now this equation is balanced. 2 Pb in the left side, 2 lead Pb in the right side. 4 nitrogens are in the left side, 4 nitrogen in the right side. If we calculate oxygen atom, we will find 6 to 12 atoms in the left side, in the reaction side, and in the product side also 2 plus 8 plus 2 is equal to 12 atoms. Hence the equation is now balanced. So this is also one example of a decomposition reaction where the lead nitrate is broken into lead oxide, nitrogen, and nitrogen dioxide and oxygen. Next example is electrolysis of water. Here when electricity is passed through water, it gives hydrogen and oxygen. So this equation is again not balanced. We'll balance it. So we can clearly see 2 molecules of water, those are broken by the passage of electricity to give 2 molecules of hydrogen molecule and 1 molecule of oxygen. So this is also a decomposition reaction. The fifth example is decomposition of silver chloride. Silver chloride is white in color. When it is exposed to sunlight, it forms silver and chlorine gas. The silver is grey in color, so white colored silver chloride is broken down into grey colored silver and chlorine gas. The sixth example is decomposition of silver bromide. As you see, silver bromide is broken in the presence of sunlight, giving rise to silver and bromine gas. So this is also an example of decomposition reaction. The decomposition reaction of silver chloride and silver bromide are used in black and white photography. You can remember this one. Next we'll discuss about exothermic reactions. These are the chemical reactions in which energy is usually released in the form of heat, and these reactions are called exothermic reaction. Normally the combination reactions are exothermic reactions. We can take some examples. Calcium oxide plus water giving rise to calcium hydroxide with the release of heat. Again, carbon when burned in the presence of oxygen, it gives carbon dioxide and heat. Similarly, here methane, it also burns in the presence of oxygen to form carbon dioxide and water and heat. So the reactions in which energy is released are called exothermic reactions. Coming to the endothermic reactions, usually the decomposition reactions require energy either in the form of heat, light or electricity for breaking the reactants. The reactions in which energy is absorbed are called endothermic reactions. Coming to the examples, we have already seen that silver chloride requires sunlight to break into silver and chlorine gas. Similarly, water, when electricity is passed through it, it gives rise to hydrogen and oxygen. And calcium carbonate, that is limestone, when heat is given to it, it is broken into calcium oxide, quicklime and carbon dioxide. In all the three cases, you see that some energy, external energy is given to the reactants to form the products. Hence, these reactions are called endothermic reactions. Thank you. Have a good day. Subscribe the channel so that we can upload more videos. Have a bright future ahead. Thank you all.